Good afternoon. My name is CZ4171 and I will be going over my course project for CZ4171 Internet of Things. The purpose of this project is to detect and classify mask wearers from non-mask wearers. The application provides an Android interface for users to easily access, and it offloads expensive computation such as inference to a server for efficiency in mobile resources. The architecture for this application is based on the server-client paradigm. Users can interact with the Android user interface, and the application will perform inference on a server machine. It will then return the result of this inference to the user interface for display through the HTTP protocol. There are two models that are used in the inference pipeline. The first is a phase detection model, which is a ResNet 10 model that has been pre-trained. And the second is a mask classification model, which uses the TensorFlow implementation of a MobileNet v2 SSD. This has been trained on a publicly available dataset, whose link you can find on the slide. To go into a little bit more detail of the dataset that was used, this dataset contains images of mask wearers and non-mask wearers, where the mask wearers have been artificially fitted with a synthetic mask. There is a limitation in this dataset, however, which is that the dataset only contains white masks, which limits the use case of this application to wearers of lighter colored masks. The tools that we used in building this application for the backend are Python and TensorFlow, among others, but these are the main two. And for the front end, we have Android Studio, and Java as the language that was used to code the front end. This slide shows the model training in progress, as you can see. The model was trained for 20 epochs because, as you can see, after about 15 to 17 epochs, what happens is the validation loss consistently exceeds the training loss, and this is a telltale sign of overfitting. For communication between the backend and the front end, we have Python's Flask library being used on the backend to set up a HTTP server for communication. This has the benefit of allowing multiple clients to communicate simultaneously with the single server running on the PC. As for the front end, Java's OKHTTP library was used for the client's access to the HTTP interface on the Android mobile device. Let's now move on to see two demos for the application. We will first go ahead and start the server side of the application. This demo demonstrates the case where there is a non-mask wearer present in the frame. Now that the server has started running, we can go ahead and start the client side. we click Start Detection and Take Photo, we can see that there is a non-mask wearer present in the frame. We can see on the server side that there has been a GET message indicating that the client has started, and a POST message for debugging. Once we hit OK, we can see that the image has been transmitted from the client side to the server side, and inference has been performed. In the terminal on the left, you can see that the result of the detection and classification is that there is one non-mask wearer present in the frame with a confidence of 98.91%. And on the right, you can see that there is a red bounding box around the frame of the non-mask wearer. Now let's move on to see what the difference is for a mask wearer who's present in the frame. This demo demonstrates the case where there is a mask wearer present in the frame. If we go ahead and start our server side again, now that the server is ready, we can go ahead and start our client application on the Android device. If we click Start Detection and Take Photo, you can see that it is taking in live input from the Android device. If we hit OK after taking the image is transmitted to the server side, and we can see in the terminal on the left that the result of the classification is mask with a classification accuracy with a confidence, of 100%. And on the client side, we can see that the mask wearer is indicated with a green bounding box around his face with the label mask and the confidence level right beside. That's all for the demo. Thank you for listening.